Hi everyone. Today a look at electrolytic cells. This is a type of electrochemical cell that is going to convert electrical energy into chemical energy. From that point of view, it's the opposite of a voltaic cell. Voltaic cells convert chemical energy into electrical energy, and here we have the opposite, electrical energy into chemical energy. The reactions that are part of electrolytic cells are non-spontaneous. That's where the oxidizing agent is below the reducing agent on our table of reduction half reactions in the data booklet. Because of all of that, they require a voltage. They're not going to have a voltmeter in their diagram. Instead, there's going to be a power supply. They're going to have a battery included in the diagram, if we have a diagram. And another way of saying that they require a voltage is they have a negative cell potential. This little subtraction that we've seen before, the cathode minus the anode, that answer there is going to be negative. All that said, the thought process that we're going to follow as we approach these questions is the same as what we followed for voltaic cells. We have this little saying, Leo's a jerk, where loss of electrons is oxidation at the anode, and it's the strongest reducing agent, the one lowest down, that goes through that process. And gain of electrons is reduction, and that happens at the cathode, done by the strongest oxidizing agent, the one highest up on the table. The only real difference to our approach, and it has to do with the wording of questions. Many times we're going to encounter the word molten. Molten sodium chloride instead of a solution of sodium chloride. This just means the chemical has been melted down. It's so hot that it's molten. It's a liquid salt. We're still going to have dissociation, so we would still put our ions into our list. Molten sodium chloride, we put sodium ions and chloride ions into our list. But because it's not aqueous, we're going to not have water present. Water is not going to go into our list. We use electrolytic cells in society for a few reasons. For the production of elements. If we actually needed some sodium or some zinc, one way to produce those elements is using electrolytic cells. To refine metals to increase their purity, that's a second reason. And electroplating. Most of the questions we encounter, as a matter of fact, are going to have to do with electroplating. So, electrolytic cells, there's some important contrasts with voltaic cells, but the thought process that we're going to follow is the same. Strongest oxidizing agent, strongest reducing agent, things like that. The little calculation to determine the cell potential is the same, only we have the expectation of a negative answer. The main thing to be on the lookout for is this idea of molten salts. When we're working with electrolytic cells, we're not going to have water present in our list if we're in a question that's talking about a molten situation. And I hope that helps.